So for project 13, part 2, you have two phases. The first one is the extrinsic phase, which you align this AI camera to the robot base frame. And what I mean by that in this case, the reference point is this part of the robot. And students tend to measure in centimeters to this part of the April tag. They usually write their measurements like this, and these are in units of meters. If you look here, it says do not move the camera. Everything calibrated, it's best not to move the camera. Once you have these measurements, you're going to enter them in your April tag known positions YAML file. For part 2, you need 3 Python scripts and the known positions YAML file. Most students figure out the Python scripts, but sometimes have difficulty with the Python dependencies. The installer bash file will install the Python dependencies needed for part 2. However, for it to run, the user needs to change the file permissions to make it executable using the change mode command as shown right there. Before downloading the files for reference purposes, know that they contain at least partially AI generated code, but the code does work for the Raspberry Pi 4B running Ubuntu 20.04. The GUI, the graphic user interface, needs to be in the same folder as the other shown files in order to work. And you want all those files inside the same folder. And so once you're inside your directory of that folder, you can use ls to look at all your Python scripts. And the first one you want to run is the detector to make sure your camera has all the April tags in the frame. So you can see here, they are in the frame. It's not perfect, but they are in frame. I'm not going to move the camera because another student has it perfectly calibrated for them. The next thing that we need to run is the April tag calibration. And what that does, the intrinsic part, and that is your pixel to 3D mapping. That means this AI OAK-D camera is going to measure the tag in 3 dimensions. As you can see here, it's collecting samples. So you can see it is pixel mapping. Sometimes this will auto quit, but ideally you want to let it run for at least 10 seconds, which is about 1,000 samples. I won't let it do that this time. And I press Q to quit that window. And now that the calibration is complete, it's time to run the auto check. As you can see, we have most of them in green or in yellow. As opposed to moving the camera to get them perfectly green, you have 2 options. At this point, you can run the calibration again, or you can make very minimal changes to the known locations YAML file. So if you use ls again, you can see what the April tag known positions YAML file is called. So you use nano as your editor. Actually, I'll open another window. That's why it said that. But if you see here, if you change this by 0.01, that will be a significant change. So be careful with that. So I recommend changing no more than 1 centimeter at a time for this. And after you do that, the next thing you want to do is run your calibration again. So from here on out, I'm going to run the GUI to demonstrate how it works. So this is the GUI. Right here you have the button to run the installer for the dependencies, the detector, calibration, the auto check, and you can conveniently open the YAML file to make any edits at ease. And we can run a calibration here pretty easily. And press Q to quit. It also says that in the title bar. Run our auto check. Press Q to quit that window. And that is pretty much it for part 2.